I'm Thirapat Tripopskunsin and I'm here with.
พัชรมนต์ดำรงกิติกุล
So let's get started with our project overview. Since the PM2.5 situation recently is increasingly concerning, especially around here at Kasetsart University. So therefore, we want to raise awareness about it, and as well as exploring their relationship. By collecting data from location near KU campus, we aim to provide user both interaction visualization and data sharing API. Despite the information is most relevant and useful for those in Kasetsart area, but the insight gained from analyzing potential relationship between those can be valuable to a broader audience also. After consider the overview, we conclude the objective, which is first explore the relationship between PM2.5 and environmental variables. Secondly, to give insight to user by integrating the data and provide them via API. And third, provide the user with an easy-to-use web app for interacting with the data for information gain.
acquisition. So our data source from the primary, we use heat right, which provide us with temperature, light, humidity from humidity sensor, PM concentration, AQI, and particle count from that sensor. The secondary, we use open weather API, which provides us with weather condition, cloud, rainfall, and wind speed. So you can see here that we collected the data for primary ourselves and then use the API to collect the secondary. So about the database design. Since the data from both primary and secondary sources are time series data, we choose to create two tables for each, which is the Raindrop Dust for primary and open weather for secondary. And then we use Node-RED to connect them to MySQL, but only two tables might not be enough. So we created the third one, which is the hourly table processing. We bin the timestamp of primary and secondary by an hour, and then group and average data in the same bin timestamp, then enjoy them, and then insert into the hourly table. And we use this table for data integration. So this is the process that I have talked about earlier, like this schema. This is the database schema diagram that we got from earlier. And you can see here, this is the attributes for Raindrop Dust. And then this is for open weather. And for hourly, that is the join table. You see here.
Let's move on to data integration. Let's recap an objective for it, but not all, just two of them. Now, consider these objectives. It came to the conclusion for our frameworks that we will use in our application, which is FastAPI for the backend and Streamlit for the frontend. Because FastAPI can handle requests, large amount of requests quickly, and can generate interactive document, which we will see in the later on, and also have a built-in validation. Let's say, for example, the response model. And for Streamlit, it have built-in components, and also can directly integrate with data analytics in Python, which is very useful and also so user-friendly. And after choosing those frameworks as a framework to use, our overall architecture is complete. So here is the overall diagram. First, we collect the data from HitWrite and OpenWeather API, then inject the data using Node-RED to MySQL database, and process from primary and secondary into hourly table. After that, we retrieve the data. The FastAPI will retrieve the data from the MySQL, and Streamlit will use the data from backend. Now, let's go and dive in to the demo. Here is the Swagger UI FastAPI provide us automatically. Now let's dive into our endpoints. First is our data latest, which will show the latest data from the database. We claim that it's real time, so here is, now it's 8 p.m., so if we execute it here, 8 p.m. That's not all. We have the data, which we can specify the start and end date. So here we limit 20 of it, so this is 20 record. The data PM, AQI, and particles do exactly the same, except that they show only PM, only AQI, and particles. Here, like here. For the summary part, now we can specify the date and the period. In this case, I specify weekly, and to execute it, now we have start time, end time, and the average, the aggregation of the data, including average, max, and also the min of that interval range. For custom, it do exactly the same, but we use start date and end date instead of the period. And the period can be weekly and daily. For the interesting part, forecast now. Forecast 1 day. Easily to predict 24 records of the next day. AQI, PM, and PM 2.5 and PM 10 value. The 3 day do exactly the same. But we use the different model and we can limit. Let's say I only want 50 hours. So here is your prediction. For this, raw is basically retrieve the data, a raw data from the database. And we can also call the API from the root, like here. We divide the page like this. We have 7 pages. Let's look at the first one, the current condition. It shows the latest data here. How the cloud, rainfall, it mentioned all. And also state the delta, how the value have changed accordingly. Oh, here. Since it's still 8 p.m., it's the latest update. And we have the statistic for today and also for the last week. Here. Now, the fun part, the fun page, explanation. If you wonder, you can look at this help. We have the peak and bottom statistics. What it can do, it shows when the data has peaked and what value at its peak, and also the bottom one. Here's the data set for here, and secondly, scalpel. Now, we can select the hue. It can be weather. Oh, but today is only cloud, I suggest. Okay. Now we can see, and it here is a scalpel, start date and end date time, and we can choose the attribute. It no need to be a timestamp. It can be AQI and let's say humidity. Here. Now the data surprisingly doesn't look that correlate. For bar chart, it's shown in the statistic, but not once, but 5. Mean, median, mode, min, and max. The data for today is a little bit too little to make useful and insightful graphs. So here, you can see And the last but not least, histogram. Of course, select hues, select datetime, and select attributes. Let it load a little bit, and a little bit too long. Now, here, we have it. And we have extra graph for user to explore. Now let's go on with the descriptive. It's basically a chart we provide to tell user like storytelling. We have the weather condition, how each attribute affects the PM 2.5, which is our main objective, right? Details, weather condition in details, how it might affect PM 2.5, and how, and other. And it's a plotly expressed, so you can interact with it. And also, look at full screen. Rain, no rain, trends, distribution, day of weeks, similar to weather, are the correlate and correlation. We use weather as well. Look, a little bit lag, and some fun exploration. Does earthquake affect PM 2.5? Does Songkran festival affect PM 2.5? It's a bit too long now. Let's move on to prediction. We have 1 day and 3 days, of course. Here, nothing fancy. The data set shown, the data sets from our database, and we can access the API endpoint using this at the front end. If you don't know how to, we have API documents for you. And that is the end of our presentation. Hope you enjoyed. Thank you for listening, and see you later.